To calculate the general lighting and general use receptacle load for a 30,000 square foot bank, we'll use the standard methods outlined in the National Electrical Code, or NEC. Firstly, we determine the lighting load. For a bank, the NEC specifies a certain volt-ampere per square foot for general lighting. In this instance, it is 3.5 volt-amps per square foot. Therefore, we multiply the area of the bank, which is 30,000 square feet, by 3.5 volt-amps per square foot. This calculation yields a total lighting load of 105,000 volt-amps. This value represents the initial demand for lighting within the bank. Secondly, we need to determine the general use receptacle load. The NEC specifies 1 volt-amp per square foot for general use receptacles in a bank. Multiplying the bank's area of 30,000 square feet by 1 volt-amp per square foot, we get a total receptacle load of 30,000 volt-amps. However, the NEC allows for demand factors to be applied to receptacle loads, particularly in commercial buildings. Demand factors recognize that not all receptacles will be in use simultaneously at their full capacity. The demand factors for receptacle loads are outlined in NEC section 220.44. This section states that for the first 10,000 volt-amps, a demand factor of 100% is applied, and for the remaining volt-amps, a demand factor of 50% is applied. Applying these demand factors to our receptacle load, we firstly consider the first 10,000 volt-amps at 100%, which equals 10,000 volt-amps. Then we consider the remaining volt-amps, which is 30,000 volt-amps minus 10,000 volt-amps, resulting in 20,000 volt-amps. Applying the 50% demand factor to this portion, we multiply 20,000 volt-amps by 0.50, which equals 10,000 volt-amps. Summing these two results, 10,000 volt-amps plus 10,000 volt-amps, gives us a total demand load for receptacles of 20,000 volt-amps. Now that we have calculated both the lighting load and the receptacle load, we can determine the total general lighting and general use receptacle load for the bank. We add the lighting load of 105,000 volt-amps to the receptacle load of 20,000 volt-amps. This results in a total load of 125,000 volt-amps. To express this in kilovolt-amps, or kVA, we divide the total volt-amps by 1,000. Thus, 125,000 volt-amps divided by 1,000 equals 125 kVA. Therefore, the total general lighting and general use receptacle load for the 30,000 square foot bank is 125 kVA. It's essential to remember that these calculations are based on general guidelines provided by the NEC. Specific local codes or unusual load characteristics might require adjustments to these figures. Always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable regulations and to accurately assess the electrical needs of the building. These calculations provide a foundation for determining the appropriate size of our electrical service, distribution equipment, and wiring for the bank. Underestimating the load can lead to overloaded circuits, equipment malfunction, and potential safety hazards. Overestimating the load can result in unnecessary expenses for equipment and installation. The NEC provides specific requirements for feeder and service calculations to ensure that electrical systems are designed and installed safely and efficiently. These requirements take into account various factors such as demand factors, diversity factors, and conductor ampacity. Conductors must be sized appropriately to carry the calculated load without overheating, and overcurrent protection devices, such as circuit breakers and fuses, must be selected to protect the conductors from overloads and short circuits. Furthermore, voltage drop calculations are essential to ensure that the voltage at the point of utilization remains within acceptable limits. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC provides guidelines for voltage drop and recommends that voltage drop on feeders and branch circuits should not exceed 3% and 5% respectively. In addition to the general lighting and receptacle loads, other electrical loads in the bank, such as HVAC systems, elevators, and data processing equipment, must also be considered when determining the total electrical load. These loads may have their own specific requirements and demand factors. It is important to gather accurate information about all electrical loads in the building to ensure that the electrical system is adequately sized and designed. Once the total electrical load has been determined, the appropriate size of electrical service can be selected. The electrical service provides the connection between the building's electrical system and the utility power grid. The size of the service is typically expressed in amps and volts. The service must be large enough to supply the total electrical load of the building without overloading. In addition to the service, the distribution equipment, such as panel boards and switchboards, must also be sized appropriately to handle the calculated load. Panel boards and switchboards distribute power to various branch circuits throughout the building. They must have sufficient capacity to accommodate the number and size of branch circuits required. Wiring must also be sized appropriately to carry the calculated load. The NEC provides tables that specify the ampacity of various types of conductors. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. Conductors must be selected based on the calculated load and the ambient temperature in which they are installed. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting conductors from overloads and short circuits. These devices are designed to interrupt the flow of current if it exceeds a certain level. Overcurrent protection devices must be selected based on the ampacity of the conductors they are protecting. Proper electrical load calculations are critical for ensuring the safety and reliability of electrical systems. Accurate calculations can help to prevent overloaded circuits, equipment malfunction, and potential safety hazards. By following the guidelines provided by the NEC and consulting with qualified electrical professionals, you can ensure that your electrical system is properly designed and installed to meet the electrical needs of your building. It's also good practice to consider future expansion when calculating the electrical load. Anticipating future growth and adding capacity to the electrical system during the initial design phase can save significant costs and disruptions later on. This can involve installing larger conduits, panels, and service equipment than are initially required. The cost of oversizing these components is often less than the cost of upgrading the electrical system later. Additionally, energy efficiency should be a primary consideration when designing the electrical system. Using energy-efficient lighting, HVAC systems, and appliances can significantly reduce energy consumption and operating costs. The NEC provides requirements for energy-efficient design, and various incentive programs are available to encourage the use of energy-efficient technologies. Regular maintenance and testing of the electrical system are also essential for ensuring its continued safety and reliability. Electrical equipment should be inspected regularly for signs of wear and tear, and any necessary repairs should be made promptly. Overcurrent protection devices should be tested periodically to ensure that they are functioning properly. Thermographic surveys can be used to detect hotspots in electrical equipment, which can indicate potential problems. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock hazard. The NEC provides detailed requirements for grounding electrical systems. Grounding electrodes, such as ground rods and ground plates, must be installed to provide a connection to the earth. Grounding conductors must be sized appropriately and connected to all metal enclosures and equipment. Surge protection is also important for protecting electrical equipment from voltage surges caused by lightning or other disturbances. Surge protective devices, or SPDs, are designed to divert surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be installed at the service entrance and at branch panels throughout the building. The selection of appropriate electrical equipment is crucial for ensuring the long-term reliability of the electrical system. Equipment should be selected based on its suitability for the intended application and its ability to withstand the environmental conditions in which it will be installed. Equipment should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertic, to ensure that it meets applicable safety standards. Proper installation practices are essential for ensuring the safe and reliable operation of the electrical system. Electrical work should be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Wiring should be installed in accordance with the manufacturer's instructions and the NEC. Connections should be made securely and properly torqued. The electrical system should be inspected and tested after installation to ensure that it is functioning properly. Documentation is an important part of the electrical system design and installation process. Accurate drawings and specifications should be prepared to document the electrical system layout, equipment specifications, and wiring details. This documentation is essential for future maintenance and modifications to the electrical system. A comprehensive operations and maintenance manual should also be provided to building owners and operators. This manual should include information on the operation, maintenance, and troubleshooting of the electrical system. Finally, it is important to stay up to date on the latest changes to the NEC and local electrical codes. The electrical industry is constantly evolving, and new technologies and regulations are being introduced on a regular basis. By staying informed, you can ensure that your electrical system is designed and installed in accordance with the latest standards. In summary, calculating the general lighting and general use receptacle load for a bank involves firstly determining the lighting load by multiplying the area by the specified volt-amps per square foot. Secondly, determining the receptacle load by multiplying the area by the volt-amps per square foot, then applying demand factors as outlined in the NEC. Thirdly, summing the lighting and receptacle loads to obtain the total load. And finally, expressing the total load in kVA. Remember to consult with qualified electrical professionals and adhere to all applicable codes and regulations to ensure a safe and reliable electrical system.